So now we'll discuss about queue. So queue abstract data type. So queue is defined as an order list which enables the insert operations to be performed at one end called rear, and delete operations can be performed at another end called front. So queue is an data structure which is similar to stacks. Unlike stack, the queue is open at both its ends. So one end is always used to insert data, and other end is used to remove the data. So queue is referred as the first in first out list. So here is the diagram for data structure of queue, that is front, rear, NQ and DQ operations. Basic operations in queue is NQ, DQ, front, isempty, is full operation. So NQ is adding a new element, DQ is deleting an item, front operation is peak operation in stack, that is it returns the value of the first element without deleting. Is empty is used to check if the queue is empty or not. Is full means it is used to check if the queue is full or not. Simple queue or linear queue. In linear queue, an insertion takes place from one end while the deletion occurs from other end. So the end at which the insertion takes place is known as rear end. End at which deletion takes place is known as front end. That is first in first out rule. So major drawback in a linear queue is insertion is done only from the rear end. So first three elements are deleted from the queue. So we cannot insert more elements even though the space is available in linear queue. So in this case, the linear queue shows the overflow condition as the rear is pointing to the last element of the queue. So this is the diagram. Circular queue. Here all the nodes are represented as circular. That is the linear queue, except that the last element of the queue is connected to the first element. It will be a ring buffer. So here the major drawback is that major drawback of the linear queue is overcome by using the circular queue. That is, if the empty space is available in the circular queue, the new element can be added in the empty space by simply incrementing the value of rear. So here the major advantage of using circular queue is better memory utilization. Priority queue. So it is a special type of queue in which the elements are arranged based on priority. So it is a special type of queue data structure in which every element has priority associated with it. So insertion in priority queue takes place based on arrival, while deletion in the priority queue occurs based on the priority. So the element with highest priority, that is here it is in decreasing priority order. So DQ and NQ operations are performed. So characteristics of priority queue. So every element in the priority has some priority associated with it. So element with higher priority will be deleted before the deletion of lesser priority. So this will be arranged using the first in first out principle. So ascending order priority queue, descending order priority queue. So ascending order means it will be in increasing order. So lower to higher. So we take the numbers from 1 to 5 arranged in ascending order. This 1, 2, 3, 4, 5. Smallest means 1 is given as the highest priority in the priority queue. So here in the diagram 2 to 11. So 2 is the element with the highest priority and 11 is the element with lowest priority. So descending order queue is higher priority is given as the higher priority. So for example, we take the numbers from 1 to 5 arranged in descending order. So in the diagram we can see 10, 9, 8, 7, 6. So 10 is taken as the element with higher priority and 6 is taken as the element with lowest priority. Heap. So heap is a tree-based data structure that performs a complete binary tree and satisfies the heap property. So here, if A is the parent node of B, then A is ordered with respect to node B for all nodes A and B in a heap. So it means that the value of parent node could be more than or equal to the value of child node, or the value of parent node could be less than or equal to the value of child node. Therefore, we can say there are two types of heaps, that is maximum heap and minimum heap. Maximum heap means the highest value will be in the first and it will be decreasing, and minimum heap is the highest, the lowest value will be at the top and it will be increasing. Priority queue operations, that is insertion, deletion and peak. So here inserting the element in a priority queue, that is maximum heap. So if we insert element in a priority queue, it will move to the empty slot by looking from top to bottom and left to right. So if the element is not in a correct place, then it will be compared with the parent node, and if it is found out of the order, the elements will be swapped. So this process continues until the element is placed in a correct position. So this is the algorithm. So starting, if no node, create node, else insert the node at the heap until it will heapify, then it will end. Removing the minimum element from the priority queue. So in maximum heap, maximum element of the root node will be there. So we remove the root node, it creates an empty slot. So the last inserted element will be added in the empty slot. So it keeps moving down the tree until the heap property is restored. So the algorithm is we have to start node that needs to be deleted in the leaf node and remove the node, else it will swap the node that needs to be deleted with the last leaf node present and remove the node and then end the condition. Applications of priority queue. So it is main applications in Dijkstra's algorithm, that is to find the shortest path between the nodes in the graph. Prim's algorithm, so to find the minimum spanning tree in the weight undirected path. Used in heap sort to sort the heap data structure. Used in operating systems, priority scheduling, load balancing, interrupt handling processes. Thank you.